Okay, welcome. In this video, we're going to prove all the special angle pairs that we've been working with, right? So we've been using them without proving them. In this video, we're going to go back and prove them. To get started, let's start off with talking about how to identify the given and what we're trying to prove from a theorem. So the first theorem is the same side exterior angle theorem. And it says, if a transversal intersects two parallel lines, then the same side exterior angles are supplementary. Okay, so whatever comes after the if is what is given. So this would be the given. We know this to be true. And whatever comes after the then is always what we're trying to prove. So the red is what we're trying to prove. The black is the given. So how you identify that is just looking at what comes after if, right? This is called the hypothesis, comes after the if, and the conclusion comes after the then. So in the next example, it has the same given. So this would be the given because it follows the if. And we're trying to prove what follows the then. All right. The first thing we need to prove is the corresponding angle postulate. Now, it's a postulate. So remember, we only prove theorems. We assume postulates. So I'm not going to do a formal proof here. But hopefully, I will talk through it. And through logic, you'll kind of believe me. Okay, so I'm not going to do this as a proof, but hopefully I give you a thorough enough explanation to where you believe me. Okay, so this proof kind of stems on the fact that these two questions: does moving something change its size or its shape? Right? Translating is just a way for moving. So say I have a triangle, and I just take the same triangle, so I'm just going to copy and paste it, but I put it over here. In other words, I moved it, right? Will it be the same size and the same shape? Yes, it will, right? I didn't do anything to the triangle. I just moved it. So I didn't change the shape or the size, so those will still be congruent. And this will always be true. If I move something, then it'll still, and they were congruent before I moved it, it'll still be congruent. Okay, so we're trying to show that the corresponding angles are congruent. So just to remind you, corresponding angles, here's the parallel lines. Corresponding angles are on the same side of the transversal, and one is an interior angle and one is an exterior angle. So exterior is outside the parallel lines and interior is inside. Okay, so that would be an example of a corresponding angle. So let's start off with just one angle. And then I'm going to try to show you that a corresponding angle is just moving an angle. So let's say I start with this angle. Okay, and let me just copy this line. Okay, and I'm going to paste it. Okay, so this line is the same line as one below it. Okay, so say I just pick this line and I just move it up. So I took this line and I moved it up, right? And I just make an angle where the mark is. Aren't those angles the same angle, right? Isn't this angle just this one, but moved up, right? And since moving it doesn't change the angle, that's why corresponding angles are congruent. Okay, if that wasn't good enough, let me show you a visual, different visual. Okay, so we're dealing with the angle below, right? If this angle is the same, when I move that angle up, it'll fit perfectly in this part right here. Okay, so as you slide it, so notice as I move that angle up, it completely fits into that angle right there. Okay, and since moving something doesn't change the angle size, they have to be congruent because all this angle is this angle moved up. Okay, that's what I mean, right? So hopefully that gives you enough justification to say that corresponding angles are congruent, right? We're going to assume this one, that's why it's a postulate. All of the angles will be theorems. So from now on, whenever you see an angle, that's a corresponding angle, you can say they're congruent by the corresponding angle postulate. Okay, so now let's prove, before we get that, it's very important to understand that this only works if the lines are parallel. So corresponding angles are not congruent if the lines are parallel. Let me give you an easy example. These lines, right, the transversal is X, but the lines here, these ones are not parallel. right? They will intersect. You could kind of visualize they'll intersect somewhere over there, right? So they're not parallel. And if I draw these angles, this is the corresponding angle with this one, you can tell that those are not the same angle, right? So it only works, very important, all of our theorems only work if the lines are parallel, okay? That's why the given in all of the proofs will start with lines that are parallel. If they're not parallel, none of our theorems work. So let's try to prove. We're going to prove these two in the video, and then you're going to prove these two as homework. Okay? The homework questions are going to be similar to the questions in this video. Here are the theorems that we've already proved. So after you prove a theorem, you can use it. So those are what we're able to use so far, right? So let's do the consecutive interior angle theorem. So first, what is given, and then what are you trying to prove? So I'd pause the video and see if you can answer those questions. Okay, the given comes after the if. So the two things that are after the if are those things. Now let's apply it to the picture, right? So which ones are the parallel lines? Well, that's M and N, right? M and N never touch. So I know that M is parallel to N. And then T, a transversal is just a line that intersects two other lines. So what we know is that M is parallel to N and T is a transversal. What we're trying to prove comes after the proof, and that's that the interior angles on the same side of the transversal are supplementary. Remember, interior angles are between the parallel lines, so I really have two options. I could show that 3 and 5 are supplementary, right? They're on the same side of the transversal and between the parallel lines. Or I could show that 4 and 6 are supplementary, okay? In this video, we're going to show that angle 3 and angle 5 are supplementary. If I do that, then I prove that all interior angles are supplementary. Okay. You could also show that 4 and 6 are supplementary, and that would do the same thing. Okay, so we're going to use these two theorems to prove it. So let's go down to the proof. So let's start with the given. The given is always the same. We know M is parallel to N. It has to be parallel, otherwise we're not going to be able to use our theorems. And T is a transversal. That's the given. Okay, we want to show that 3 and 5 are supplementary. So how we do that is we think to ourselves, is there any other angle that is supplementary to to 3? Well, we know from previous lessons that 1 and 3 are supplementary because they form a half circle. That's called a linear pair. So I'm going to say that angle 1 and angle 3 are supplementary. I'm going to say supple because I'm out of space, but that means supplementary, right? And the reason is it's a linear pair. Anytime angles are right next to each other and they form a half circle, that's the linear pair postulate. Okay? And in the previous proof, in the previous postulate, we already established that 1 and 5 are congruent. So 1 is congruent to 5. That's the corresponding angle postulate. Okay, now what does it mean to be congruent? Well, first, let's do supplementary. If 1 and 3 are supplementary, what does it mean to be supplementary? So the definition of supplementary says that if they're supplementary, that means they add up to 180. So I'm going to say since 1 and 3 are supplementary, that means that 1 plus 3, the measure of 1 plus the measure of 3 is 180. Okay? And if 1 and 5 are congruent, then the definition of congruent means they're the same measure. Right? So I'm just going to rewrite it. That means that the measure of 1 equals the measure of 5. Okay, so since they're congruent, that means their measures are equal, right? And since these are supplementary, that means they add up to 180. Now we're trying to show that 3 and 5 are supplementary. Well, 1 and 3 are supplementary, but it isn't 1 equal to 5. So I could replace this 1 with 5. So I'm just going to write this equation again, but I'm going to replace 1 with 5. The word for replace in math is substitution. Okay, well, we know that they add up to 180. And so if they add up to 180, that means they're supplementary. If someone were to ask you what supplementary means, you would say they add up to 180. So since 5 and 3 add up to 180, that means that 5 and 3 are supplementary. And that's what we're trying to prove. Right? How do we know they're supplementary? Well, that's the definition of supplementary. If somebody were to ask you what does supplementary mean, well, they add up to 180, right? So since 3 and 5 add up to 180, that means that they're supplementary. Okay, so we have just proved that consecutive interior angles are supplementary. So now whenever I see a consecutive interior angle, I can use the consecutive interior angle theorem to show that they are supplementary. All right, last one. Now we want to show that the alternate interior angles are congruent. So what is given? So it says if a transversal intersects two parallel lines. So again, the parallel lines are M and N. So we know that M and N are parallel, right? These are the parallel lines. So we know that M is parallel to N, and we know that T is a transversal. Alternate interior angles are on the opposite side of the transversal, but between the parallel lines. So we have two options. We can show that 3 is congruent to 6, because those are alternate interior angles. Or we can show that 4 is congruent to 5. Okay? Which one do I do in this proof? Okay, so it doesn't matter which one you prove, but I'm going to show that 4 is congruent to 5. That's what we're trying to prove. If we prove that, then we can show that all the alternate interior angles are congruent. All right, so now let's do it. So let's start with the given. The given is M is parallel to N, and T is a transversal. You're just going to fill in the missing statements and reasons. Okay, well, 4 and 6 are supplementary. What type of angles are 4 and 6? Well, they're interior angles, and they're on the same side of the line. So they're consecutive interior angles. So the theorem that tells us they're supplementary are the consecutive. We just proved this. The consecutive interior angle theorem. Okay, well, if they're supplementary, what does it mean to be supplementary? Well, that means that they must add up to 180 degrees. Okay, 5 and 6. So how do I know that 5 and 6 are supplementary? Well, they make a half circle. They're right next to each other. So that's the linear pair postulate. Anytime you have angles that are right next to each other, those are called adjacent angles, and they form a half circle together, that would be a linear pair. What does it mean to be supplementary? Well, that means that they add up to 180. Now, we have two things that are adding up to 180. So both of these things are 180. So two things that are equal to the same thing are equal to each other. That's the transitive property. So the things that are equal to the same thing are 4 plus 5 and 5 plus 6. Sorry, 4 plus 6 and 5 plus 6. So since they're both equal to 180, that means they have to be equal to each other. And why is that important? Well, now we have angle 6 on both sides of the equation. All right? So we have to say first that anything is equal to itself. So angle 6 is equal to angle 6. Now the reason why that's important is because if it's equal to itself, so let's think about like 3x plus 5 equals 6 plus 5, right? Well, if the 5s are on both sides, right, then when I subtract them, they'll cancel out because they're exactly the same, right? Use that same logic here. If I subtract the 6's, then the 6's would cancel out. And I would just get left with 4 and 5, and that's exactly what I'm trying to prove. So that's the subtraction property. If I subtract angle 6 from both sides, angle 6 is equal to angle 6, so when I subtract them from each other, they're just going to cancel out. And now I've shown that the measures are equal. If the measures are equal, then that means they're congruent. And we've proved that the alternate interior angles are congruent. That is it for this video.